My name's Carly Richmond. I'm a senior developer advocate at Elastic, and this is our new session of the London Java community, which is sponsored by RecWorks, which is a recruitment company based in the UK. Today we have part 2 in Michael's series on records, which we're excited to see today. So Michael Mirwaldt lives in Munich, Germany, graduated with a degree in computer science at LMU, has 18 years experience with Java, worked for 10 as a Java backend developer full-time, has given 2 talks about streams, contributed samples to JMH and JCStress, and also has played improvisational theatre in his spare time for the past 13 years and is a proud uncle of 2 nieces and 1 nephew. And he's going to be talking all about records today. If you didn't catch part 1 of his talk, it is up on the LJC YouTube as well, so you can go and check that out afterwards. But with that, Michael, I'll hand over to you.
Thank you very much, Carly. First, I would like to say some things before I forget. First, I usually give people some time, half a minute or 1 minute, to read my slides, to understand the examples, to think about them. So if I don't talk for half a minute or something, I still live, I'm not dead. Because I once noticed that it's very hard to read a slide, to think, and to listen at the same time. The second thing is, if you have some more questions, then just give it to me via the chat. Otherwise, if it is more discussion or something else which takes a bit more time, then please be patient and ask me at the end of the talk about that. However, I would like first to start with you with a short poll, because I'm always interested which Java versions, for example, you use. Can you shortly write in the chat the number 11, 8, 17, which Java versions you use at the moment, or which one you use? That would be quite interesting for me. I can't see. Ah, wonderful. Now there are numbers. 11, 17, 11. Okay. You know that the records were introduced in Java 16, and in Java 11 you can't use them yet. But maybe I can give you a convincing argument for your customer or for your company really to switch to at least Java 17. If you have the chance to go to Java 21, would be better, I think. But I know that you're not free in your decision always. Thank you. That's nice and interesting. What I would also like to know from those people who vote 17, 19, and 21, have you used records yet? So a Y or an N for no would be interesting. Okay. Wonderful. That's interesting. I also want to mention that it is not a shame if you haven't watched the first talk of these 2 talks. It's not a requirement, but it would be, of course, helpful if you watched it. Okay, wonderful. Then let's start. You have already introduced me, Kali. Thank you. So I can spend some time here with that slide. I would like to have a general remark on that, because if you show something what I want to show you now, you always might think something like, does it really make sense? And it's nearly always a kind of trade-off between solutions, whether you want to have a fast solution or flexible solution, or if you just want to have a simple solution. I want to today show you a simple solution for a compiler, but it won't be really very fast or flexible as professional tools. However, this should just add you an option if you have some small languages. First, I will give you some ideas how you can make those language be more readable in a human-friendly way without any constructor calls. And then I will show you the parser directly. Of course, I am afraid last time the first examples were too simple, so that some people might have thought if this continues, then it might be not challenging enough. So I just put it in at the beginning now. After that, we will talk about simplification, which can be optimization, but must not always be optimization. But it is typical for a compiler to optimize. I don't know if you has learned that 80% of a compiler nowadays is only code to optimize what's already there in the abstract syntax tree. And after that, of course, you want to somehow have something executable, computable. And that's why we will compile it to a lambda expression. And then at the end, of course, a short summary and then questions. Okay, first, I want to point out this is a compound example that I use now everywhere in the talk. I hope you are familiar with those Boolean expressions that you see in conditions for if clauses or while clauses or for loops and that. I also decided to use the exclamation mark, the ampersand characters, which are quite typical for those operators in C, C++, Java. I avoided the mathematical symbols. So it should be easier for you to read my examples. I want to also point out that I just left out things like not and implication and that stuff. We don't need it. I also want to point out that the precedence of operators is very important, and it will challenge us from time to time. You will see. I don't declare in my examples the variables A, B, C, D, E. So just think of some variables that create variable objects which are then implicitly used. I want to point out that some might think, well, propositional logic, is this somehow comparable to something that you use in your project? Well, you can somehow consider it as a kind of domain-specific language, because I think some patterns and some challenges are similar. And if you think of that, then you might see more, it might appear more useful to you. And last but not least, as I said before, this is really a simple solution, in my opinion, not a fast solution or very flexible solution. If that is critical for you, then please use something like Andler or Yak and all those tools, because this approach here is not made for being fast and very flexible. Sometimes, however, your language stays small, and then it might be somehow an overkill and over-engineering if you use tools like Andler, at least in my opinion. Good. Let's see the first example. Some might know it from the last time. Here are sealed interfaces, which somehow define the basic expression parts which I use. Just have a read. Okay. Who of you has heard about that sealed interfaces and sealed types? They are quite new. I think they were introduced in Java 2021 something. So it's quite new. If you don't know it yet, that might not be a big surprise. So a Y for yes and N for no. Who of you knows about sealed types? Okay. It's not a problem if you don't know it, because in a nutshell, you can restrict which classes may implement an interface, and the compiler will check and make sure that those interfaces are only implemented by those classes which are permitted. And this allows, for example, that if you have switch cases, that you don't need a default case in the end if your cases are exhaustive. So it's pretty useful. And that's why I use it here. But if you haven't yet used them or not, you are not yet familiar with them, it's not a big problem. Okay. Here you see the second slide. And if you noticed before, sorry if I jump back, you see here static and default methods. And they are actually all factory methods. And those factory methods help us to define a Fluent API that might be easier to read than constructor calls and other notations. Look at this here in line 8 to 12, and to see what a big difference it makes, at least for me. So another small poll, who of you likes those expressions in line 10, 11, 12 more than in line 9 with all those constructor calls? And Y for yes, it's better, or an N for no. It is still ugly. To me, it seems really that it makes a difference. Because in fact, the constructor calls are actually somehow postfix. Okay. You noticed in line 14 to 17 that there is a problem in it. And as you might remember, just a moment before, I talked about the precedence of operators. And if you do something like infix, then so with the operator in the middle, then you might somehow create expressions that are actually wrong. And if you look into line 15, you see that you get constructed or B or C and D, but you all know that and has a higher precedence than the or, and we just do the wrong thing. You can, of course, have some workarounds as in line 16, that would be correct then. But you must be careful in line 17 if you just put some brackets around it. As you might all know, it has no influence. Either you put the brackets between B or C or not, it makes no difference. So you must be careful with that. We can, however, fix that just by a trick that if we notice that this happens, that we somehow fix it at that moment where that situation might happen. And you can somehow rearrange some expressions like here. Okay, I hope that was not too difficult for you, but keep in mind when you design some Fluent APIs for your small languages with records, not to run into those pitfalls and confuse your users. Now, we can make it even more simple. If you just look before here, we always had to somehow use the constants and the variables declared. And actually, this is not really necessary, because if you just support strings and Boolean values, then you can directly put them into and get expressions like in line 17, where you can just directly put it into. So these methods that you see here, they are additional to the other methods from before. I'm sorry that there was a small mistake. The from should actually be a with in line 5 to 8. I have noticed it. So please don't get confused. With and from should be the same. I need to write it down to fix it. Okay, so you see that we have just only parameters which are strings or booleans, which makes it, I think, more comfortable to use that API. I can recommend you to introduce a method like with. Be careful with off, because in IntelliJ and other IDEs, you usually get proposed list off and map off, which can sometimes be a bit annoying. And as you see, you can just start with an with false in line 17, and from that on, the type is clear, and then you can just use all those factory methods to stay type safe. However, there are some small issues. I mean, if you just look with that not with C at the middle, then you will notice that whenever you start an expression somewhere, you must start with the with method. But I think that's not so terrible. Okay, who of you has heard about grammars, and who has once learned about compiler, how to craft compilers? Don't be afraid. It's no shame that you have never really considered or learned something about them, except you have studied computer science like me, because then you had to learn it usually. Yeah, eBNF is wonderful. That's a white word here, the Bacchus now from the extended. Just ignore for the fact that this is those are German words that I've got on the slide. For those who don't know so much about it. In a nutshell, you have here some rules, and you have terminals and non-terminals. Terminals means it ends here. Non-terminal means we can replace more. And usually you have those variables. Here I use small letters. Usually you use capital letters, but this is only because the variables here that I use in that language, they are capital letters. And if I would somehow confuse them, the variables and the symbols here, that might cause problems. However, you can understand it like this, that this grammar here sets rules how to create valid expressions. And you must always be able to follow those rules to check whether an expression is valid from the syntax or not. There are also syntax diagrams. That is these with the arrows you see right. If you think of terminals, it means that you always have true, false, and then here some might have noticed it yet. It's the regular expression for all capital letters from A to E, from G to S, from U to Z. I omitted here F and T because true and false starts with them, and that might be quite confusing and make things terribly complicated, where it doesn't matter, or it shouldn't matter, in my opinion. So it ends with that, but it would be quite boring if you only can create expression with one symbol. You want to combine them. And that is in line 12 to 16. There are some rules. And those E's here, they mean that you can replace something. So it's all about replacing. And in the end, there may not be something to replace anymore. So in the end, you end up with that symbols here, and you end up with this variables and that constants. So that's a basic idea. I don't want to now explain you what LL parsers and all that is. It doesn't matter, at least not for this talk here. However, I must warn you, if you use professional tools like Antler or Yak and Bison and all those, you should know about grammars, in my opinion. Otherwise, we will get into problems and not really understand what actually happens and why things fail. That's, by the way, also a benefit from this approach that I show you now, that you must not define your language as a grammar, because I think all those tools, they all expect a grammar in the end, as far as I know. However, a grammar like this is, I would claim, always helpful, especially for testing those. But that's so far about compilers. Just think of those as rules that tell you how you can create expressions. Now, we just create a primitive bottom-up parser here. That means it takes the expression you give it to that method, and then it tries all the time to replace until it cannot replace anymore. And if it notices that there are still things left that cannot be replaced, then it will throw you an illegal argument exception here and tell you at that position, I don't know how to read that. In the end, it will somehow consume your expression and step by step translate that string expression to that expression in our language. Here you see that we do everything step by step, which is not very efficient, but it's easier to understand, I think. I want to point out here that might not have to use that position here, but please do me a favor. 90% of all error messages that I see have no useful information in it. And I think it's very sad that we really don't use error messages to understand what failed. And that's why here I just introduced it with a position that we can really say at that point, that string I can read, because if you just give out cannot pass and blah, that's all, it's extremely difficult to understand what went wrong, and then you must always debug. And I think you must debug it. You should somehow get some message that helps you without debugging. You also see here that in line 4 to 9, I use optionals. And I use that or method, which says only if there is nothing present already, then do this next. Also, you see here, those are suppliers. That means they are not called unless it's needed. So if pass constant in line 4 gives an expression, then all the other expressions are not the other lines are not executed, which is important. Otherwise, we would get very strange results. I want to point out here, you cannot create a language which has something like brackets with only regular expressions. For those who have studied computer science or know a lot about compilers and languages in the computer science context, they are not powerful enough. However, Java has not only regular expressions, but also a mechanism called groups, where you can extract what you have parsed. And if you then evaluate that in a recursive way, then you can implement a compiler with it, with all those expressions, and then it's enough to parse language expressions. Okay, how does it look like? Who of you has used that pattern class or pattern object with regular expressions? I think they are very old. They had been there for Java 1.2, 1.5. Very old, but still working quite well, at least for me. So who of you uses it from time to time? Why for yes and for no? Something in the chat would be interesting for me. I would be surprised if nobody uses it. I see 2 Ys. Wonderful, then I don't need to explain a lot about it. Yeah, you're right when you say that you have to be careful with regular expressions. You can also create very difficult expressions that are hard to understand. I hope that these ones that you see here are quite easy. In the first, you see the constants, and then the second, you see variables. The only thing you need to take care of is that a regular expression nearly always matches when it finds a variable in it. And so you somehow have to make sure that you have a full match, so that you really match only that and out of any context. So, because if you have brackets and a variable in it, all those patterns would always somehow match, but you want to make sure that they only match if there's only a variable in it, nothing else. And that is very important here. Otherwise, this approach wouldn't work. Now it gets unfortunately a bit complicated, because with regular expressions, as I said before, you cannot really define brackets in the context that there is always an opening bracket and a closed bracket, and they are in an order that makes sense. And this is how I solved it. Take care of the 3 edge cases at the beginning from line 1 to 4, because it can get quite confusing. Okay, I just shortly explain it to you for those who might not really understood what's going on there, because you see it as a very long condition in the if clause. What we actually must make sure is, as you see, that we only check for the first and the third edge case in line 2 and 4, because in those cases we somehow must extract something, and we must extract what's in the brackets. However, we may not do it in the edge case in line 3, the second example, because then we would somehow would have in our expression the closing bracket of A and the opening bracket of 2, which makes no sense, because the opening bracket of A is closed after A and not closed after 2. However, if you consider that, then it's still quite simple, because even if you have the fourth edge case that you have a combination of 1 and 2 or something, you still can handle it. And this solution works as it only checks whether it has 1 or 2 brackets at the end, and it has no interfering brackets between. Okay, now we get to the not pattern. Here we have to deal once again with issues that the not operator is not just on one variable or a constant, but also for another expression like and or. For those who noticed it, first and second should be left and right. Okay, what's going on here? In short, if the following expression of the not is an and an or an or, it must this not operator applies to all of the expression, so all operands of that operator, not just the first one. And that's why we must be careful here. It's actually that's the point that the not operator has a higher precedence than and or, and we must keep that in mind. Okay. Now to the end pattern, we also have there a small problem that we also must keep in mind, that when we face OR expressions, that we have to connect the operands the right way, so that AND has a higher precedence than OR. Okay, you see in line 7, when we have on the left an OR, then we have to somehow put the right operand of OR, or the second one, to the end, because AND binds stronger than OR. And it's the same on in the other direction. And if we don't have any OR, then we can just put it into an AND object. And last but not least, OR. And I want to point out the order in which we parse the patterns is not arbitrary, of course. It is in the order of precedence. And that makes it more simple for us. So here you see there's nothing special anymore. Okay. Now we get to the more interesting part, that we have now our expression. However, we can simplify it. And the first thing we can do is, for example, that if something is included in another expression, that we just omit it. We remove it because we don't need it. And therefore, we have that contains method for AND and OR. And you see those examples in line 6 and 13, where we can shorten things. It's important to point out that, of course, we must always make sure that we may not confuse the operations. So you see in line 7, if I have an AND and I get an OR, it's of course not included. It's only included if we have a chain of AND operations. Then we can omit something, possibly. However, that's only the preparation for the more advanced optimizations. You might know them from computer science, and here there are some examples for it. What you can simplify. Okay, there was a question. Yeah, this short circuit evaluation, yes. I mean, if you, for example, look a moment. I've got not a case here. Oh, wait, one moment. If you look, for example, in line 9, and we know, for example, that the first operand, the left one, is false, then we don't need to check the right one anymore, because false in an AND always leads to false. And so, yes, that short circuit evaluation is here considered, and we can simplify the expressions in that way. So yes, line 9 and 10 our examples for short circuit. Well observed. Okay, something you might not have noticed yet is that I call this method simplify once, and with once I mean only one step. It's quite tempting here to try to have some recursive calls and somehow simplify it as far as you can do, but the problem is you will most of the time run into an infinite recursion because your cases will become very complicated. And believe me, I tried it out. And there's a better approach for it. And also, when you only always make sure that you apply one simplification, then your cases here, as you see, apart from that on the bottom, from line 13 to 16, you only optimize one thing and you have no recursive call in it. And so step by step, we simplify. And if you now wonder, well, how can we make sure that we really simplify as much as possible? You can do it like this, that you have a simplify all method. And now what you do is you just all simplify once so often that when the result you get is the same that you had before, then you know there is no chance to optimize anymore, or no way to simplify it anymore. And then you can stop. And as our rules have no circles in it, it will always end sometime. And this approach also has the big advantage that it's easier to debug, because as you can see, if you just always see one intermediate result and see, okay, this time this was simplified here, and then this was simplified, it's much easier. And as you can see below, then you can just have that simplify all call, and then you get the smallest expression. One small thing here is that as we also here apply the distributive law that you might know from sums, you know, when you multiply to sums a plus b in brackets times c plus d, that you get those pairs, you know, a times c plus b times c plus b times c, and then no, b times c plus b times d. And that also applies to the logical expressions here as well. And in the end, as far as I know and think, you will end up in the distributive normal form, where you really have end expressions separated by ors. And from there, you can theoretically optimize further. I haven't done it yet because it leads too far, and it's not so easy as it sounds. However, I want to point out that this method here, you know, I omitted something like 12, and there were at least 5 or 10 more lines about OR. And if you have one method like this one here, so long, split it. Because it might get longer and longer and longer, and more difficult to debug, more difficult to understand. And that's why on the next slide, I want to propose you that you just introduce a simplify method on the expression themselves and somehow delegate the simplification to them, because then you can really focus on what you can optimize when you have a specific expression, because it depends from that expression what you can simplify. And here, for example, for not, you see you can only just invert the constant, or you can just get rid of double negation. But apart from that, and also you see here, when you have and ors, you have to consider the De Morgan's law, where it inverts the operation and the operands get negated, like here. And otherwise, as you see in line 12, you just delegate it to the sub-expressions if you can't optimize something or simplify something. This approach has really the big advantage that you get smaller switch pattern, switch blocks. And if you, for example, look for a rule and maybe it's not, then you might know much easier where to find those rules. Then you must not just scroll down and down and down in your IDE. You see that you can do that for and as well. It's something like this here. You might see something which you don't like. And you see all the whens. And the whens are quite ugly, but at the moment, you cannot really avoid it. You see, those rules are the same as we had before, but now I put them all onto the slide because I had enough space. And also, as you see, I introduced some helper methods like is distributive and to not to spoil all the place in the switch block for it. And what you actually want to have is something like this. It's called constant patterns. Unfortunately, Java doesn't support it yet. I don't know if Kotlin already supports it. I must confess, I don't know. I know for sure that SML, functional programming language that I had to learn when I studied computer science, knows constant patterns, but it's a functional programming language and a completely different paradigm. But as you see here, that would be even more nice if you could somehow write it down like this here. It looks a bit also like Prolog, to me at least. It would be much more concise if this was possible. I asked, by the way, somebody of the OpenJDK people, and they said that it's on their plan, but they cannot tell you when it will come. But it's a hot candidate that it will come soon. So that with the records and the pattern matching, it's not the end, it's actually the beginning at the moment. Yeah, I also think that it is easier to analyze as well if you have it much shorter and really focused on one thing and not on different constructs. Here, by the way, you see also that with the contains in line 10 and 11, here we use it, and we somehow can omit then things we don't need. And that will come, as I said, but I don't know when. And now, last but not least, usually a compiler creates something executable. In this case here, I thought of to make it a predicate where you can just pass a map with values for variables, and then this predicate evaluates it for you. And you don't need to care anymore what actually happens there. And you see, it's not very complicated. At least I hope so. One small thing, but I must warn you, in Java 21, there is that unnamed variables that you can use with an underscore. Unfortunately, I've noticed that there is one very nasty and ugly bug that leads it to the situation that whenever you somehow have a lambda and return it, that you get a exception from the compiler, I think, where it says quote, quote, name is missing. And I think it was already fixed, but you somehow, unfortunately, must be careful with that unnamed variable at the moment. So in case you see that exception or error message, then just, as you see here in line 3, you replace it by just any name. And it only happens, as far as I know, if you have the debugger option with the names, with the debugging information enabled, which is usually enabled by default in IntelliJ. But of course, you can, if you want to have smaller jar files, just remove it, the debug information or then those names. Okay, and that was so far my small compiler, quite primitive, but effective. And I can recommend you only that you somehow experiment with prefix, infix, postfix notation to make it easier to create expressions within the programming language. Those switch blocks I would always recommend into parts that they are much too long. Usually it's not so difficult. Simplify, as I showed you before, step by step. Don't try to do it at once with one call and one recursion. And this primitive compiler, as you see here, has really a small number of lines of code. It's easier to debug it because if you use something like Antler, I'm not sure if you can debug it in an easy way because there are very sophisticated algorithms in it, as far as I know. So here you have all control over the compiler. And that can be an advantage. And as you see, this is a quite primitive and simple compiler. I also think that it is very nice that you can write such a small compiler with all those pattern matching and records. I think it was much more difficult 10 years ago where you hadn't things like that. And once again, please, if performance is critical or flexibility, then don't use this approach because I don't think you will optimize it in a way that it fits in the end for you. But keep that as option. Not every language is as complex as a programming language and needs Endler. Okay, do we have some questions or some ideas? Or I know that it is sometimes a bit controversial whether you should write your own compiler or not. Some people might think you are insane because they think there are so many tools for it. Why should you? I sometimes notice that you must be careful that you cannot expect everybody to know everything about compilers. Many software developers have never studied computer science and they've never had the time to learn that or wanted to learn that. And with tools like Antler, you can also do very stupid things if you don't know. And that's why this approach here, for example, if this one is enough, you don't need to explain your colleagues very much about compilers. So this is a big advantage of that approach. So my last question for you, has anybody of you written a compiler or a parser in his career already? A Y for yes and N for no? It would be quite interesting for me. It can also be a small formula parser that sees that passes some Excel formulas or something. I've heard that was done 20 years ago several times. I hope those examples that I showed you now might be inspiring for you. And I wish you all the best. And thank you, Carly.
Oh no, thank you, Michael. Has anyone got any last questions at all that they want to share? Either come off mute, raise your hand, or the chat's there as well. Nope. Okay, well, thank you very much, Michael, for taking us through records. Obviously, you mentioned part one as well, so anyone who came today who hasn't seen that, go check out the YouTube channel for LJC. This session will also get posted up there as well, and we'll catch you all at the next event.
Before I forget, Carly, before you end, of course, I will publish the slides. And I've got also a GitHub repo with tests where you can execute the code and things like that. I've yet not published it, but it will come the next days at the weekend. And I would just give you that information where those people can try it out if they want to really watch simplifications or watch the parsing if they want to know it in more detail.
Yeah,
so that will come soon. Okay, thank you very much. I always like it if you can somehow help you with those small tricks and also so sometimes things like that here really show how powerful some features of programming languages are, and sometimes it is underestimated or quite underused, and that's sometimes a pity. That's why I give talks like this one here to show them here some small tricks with huge effect. Okay, thank you very much. See you next time.